This is the tutorial for graphing absolute value equations, chapter 5, section 8. So let's take a look at our examples that we'll end up seeing. And the first thing to do is whenever we've got a graph and we're unsure how to do it, you could always set up a t-chart and go ahead and plug some values in, some inputs in, and come up with some outputs. So before we even graph these down here, let's take a look at just y equals the absolute value of x. Because once we figure this out, then we can use some concepts to help us figure out what these end up looking like. And whenever I graph a y equals absolute value of x, if I didn't know what to graph to start with, I'd probably pick these values here at least to come up with and then get the general shape of the graph. And so whenever I plug in a -2 in for x, when I take the absolute value, I end up with a positive. And so these are the different values that I'd end up coming up with. And so when I look at that, I see that just a quick sketch shows me that as my values end up getting bigger, when I get to 0, my y values are decreasing. But then once I hit 0, I go up to 1, they end up increasing. So this is kind of what it looks like. It's a decreasing line when I get to 0, but then it increases the same way it decreased. And so what we end up coming up with is a V shape, and that's the general shape that we're going to have. And so what I call this is a parent graph. And so the parent graph is kind of just the general shape of the graph, and then there's different things that will change it. Like, for instance, here they say we're going to take away 6 from the parent graph. Well, what would that look like? Well, again, if we're unsure, we could go ahead and take a look at a t-chart, plugging in the same values and seeing what happens. And so again, if you plug in -2, you end up getting 2, but then you got to take 6 away from that, and that's going to bring you down to -4. And so if you start at -1, you end up getting a 1 when you take its absolute value. You take away 6, and you end up at -5. And then we go ahead and plug in 0, and we just get -6. And then once you plug in 1, we bounce back up. And so you see how you end up at -5. When you take the absolute value of 1, it's 1, minus 6 is -5. When we plug 2 in, that brings us back up to -4. So what's happening is we're end up having the same shape, except it's starting down on the y-axis, down to -6 for the lowest point. And so here's the general shape. This allows me to go 5. So I think I'll end up putting a dot right here for 6, and then you see how we get a point here, and then it goes back up. And so you can see that we have the same exact shape. The difference is that it ends up moving down 6 spaces. And what brought it down? Well, it is -6. And see, if you cover up the x, cancel that term out, you're left with y equals -6. So you know that's the y-intercept. And so that's what it ends up looking like. So if it were a y is the absolute value of x plus 3, well, the only thing that would be different is we'd end up adding 3 to each of the values. So it would be the same general shape, but just up 3 spaces along the y-axis. And that's what ends up happening when we add a number or take a number away from the absolute value. It just moves along the y-axis. So that's the type of problem that we see here, where we have the absolute value and then something being added or subtracted from it. But this is a little different. So we're going to use the same absolute value function, but this time we're putting the number inside the absolute value bar. So let's see what happens. And so maybe this one is a little easier to see if we just go ahead and talk about it. And we'll do that one first, then we'll move over to the one with the decimal. So we'll pick the same values for now. Let's go ahead and pick -2. And when we plug that in, see, now we have to subtract 1 first rather than taking the absolute value. And so that gives us -3, but then the absolute value is +3. So we plug in -1, that makes a -2, and then taking the absolute value makes a +2. Plugging in 0 gives us -1, and then the absolute value of that is 1. So you see how now, on the other problems, we always ended up with 0 when we plugged in 0. Here, we plug in 0 and we got 1, because we had to subtract 1 from it and then take the absolute value. So we don't hit 0 until we plug in 1. 1 minus 1 is 0, so there we finally hit 0. And then we plug in 2. 2 minus 1 is 1. And then we bounce back up at 1, so you can see how those two are the same. So you can imagine if I plug in 3, I'll end up at 2, and that's the case, because 3 minus 1 makes 2. And so that would give me +2. And so when I go ahead and graph these points, over 2 spaces and up 3 spaces, I end up with a graph that ends up doing this. it ends up coming and hitting the graph right at the x-axis at positive 1. That's what you see right here. See that bottom point, that vertex. The vertex is this point where it changes from a negative slope to a positive slope. That changes right there at positive 1, so that's where the vertex is. Before, the vertices were always at 0, 0, or at 0, negative 6, or at the 0, positive 3. So let's take a look at one more point here. I graphed 3, 2, and so you can see how it ends up going up. So you see what happens when we take away 1 from the x value. We end up having to add 1 to be able to get it that vertex there. And so that's why when we have to add 1 to x, that's where it ends up hitting that vertex. So like on this one here, at x equals, or negative 2.5 is going to be where that vertex is going to end up being. So if we go 2.5 spaces over right here, that's where the vertex will be, and it'll have that same exact shape. So again, if I subtract and have negative 2.5 plus 2.5 will make 0, and so that's where that point will be, where that vertex will end up going. And then from there, it'll have that same exact shape. So you see, when we go ahead and add a number to the x value inside the absolute value, you're going to end up having to subtract or go in the opposite direction. The vertex is going to be in the opposite direction of this sign, because in order to make that 0, you have to have an opposite sign. And the negative 2.5 would end up making that 0, that vertex point. Where on this one, when we are subtracting, we'd have to have a positive 1 in order to make 0 here. And that's why you always end up going the opposite direction of what this sign ends up telling you inside the absolute value bars. So let's take a look at another problem. Here we have similar situation, but now we have a minus sign outside the absolute value bar. So let's see what happens here. So if we just take a look at this situation where I had just the y equals the opposite of the absolute value of x. Let's take a look at what that would be. So let's plug in some numbers. We'll plug in these same values, and we'll sketch the graph. So negative 2 in for x makes a positive 2, but then I have to take its opposite, so that's why it's negative. So this minus sign on the outside is kind of like negative 1 being multiplied by the absolute value. So once you take an absolute value, you end up with a positive, but then multiplying by negative 1 always will make a negative. So you're going to get the same values, except they're going to always be the opposite sign. And so that's why the values are negative. Now let's see what happens when we go ahead and graph that. Well, what happens is the graph kind of is turned upside down. It ends up going in a V direction, same sort of V direction, but upside down rather than right side up. And that's what we see with the minus sign on the outside. So when we look at this, we're going to end up with a vertex, first of all, at positive 3 on the x-axis, because 3 minus 3 is going to make 0. So if I add 3, I'll end up at the vertex right there. Now this minus sign, though, tells me that, okay, it's going to end up going, heading this graph downhill from left to right as we go ahead and draw those in there. So as we draw the one heading down to the left, it's going to go down to the left, and this one is going to go down to the right. And so taking a look at this one, here we are starting down at negative 3 on the x-axis, or the y-axis, because we're taking 3 away from the absolute value, and then it does the same thing where it heads down, opens down because of that negative sign on the outside of the absolute value bars. Well, let's take a look at the next one. Now, these graphs are called piecewise. It's a type of piecewise graph. And a piecewise graph, or piecewise function, is one in which a function with different rules with, or for, we'll say, for different parts of the domain. So the domain runs along the x-axis. And so when we look at this, when we're going along the x-axis, we see, okay, this graph is heading uphill, but then it heads downhill. So usually on a regular linear function, it's always going to be heading the same direction, where here, a piecewise means that it ends up switching on you. And so we're going to see another example of a piecewise graph on this next problem here. And here they give us some different values for x's and some dosages. So the weight is going to depend, or the dosage is going to depend on the weight. And so that typically makes sense. So you're going to end up having a smaller dosage if you end up being lighter, where if you're heavier, your body can handle a little bit more of that, where it's going to take more medicine for you to be affected by this. So it says here, the table at right shows the dosage of a certain medication for child's weight. Graph the step function. So we're going to see what one looks like. And so a step function is going to look like steps, like a staircase, and that's what we'll end up seeing here. So as I talked about before, the weight is independent. That can change. It's in pounds, but the dosage is going to end up depending upon how much a child weighs. And so we're going up by 25. So let's see if we've got room. I'm going to go ahead and call 2 spaces up. We'll call this one 25 here, and we'll call this one 50 at 4 spaces up, and we'll just continue on. So this would be 75, and this would be 100. And these are in milligrams. And then I've got the weights, and I need to get all the way to 27, so I'm going to end up going by 3s here. And so if I count my spaces, I've got 10 spaces. So if I divide 10 into 30, which is pretty close to what I need to go up to, that tells me I need to go up by 3s. So I'm going to put a 6 here, 12, this is going to be 18. So each line is 3 spaces, but I'm not going to write each of them so I don't clutter the graph. And I ended up at 30. And so now we're going to use a step function to go ahead and graph these. So you see how 9 at 25 milligrams, you're going to use that dosage for children that weigh between 9 and 11 pounds. But notice the inequality sign. So 9 is going to be a value that we'd end up using. So 25 milligrams at 9 pounds. So I got to use a solid circle because 9 pounds is a solution, and it goes all the way to 11. So there's 12, and 10 is going to be, so this is 9, 10, 11, so 11 is going to be about right here. So it's going to be an open circle and a line between, and it's an open circle because of the inequality sign we have here. And then at 50, we're going to have a closed circle on the 11. So an 11-pound child does not get the 25 milligrams. He gets a 50 milligram dosage. But everything up to the 11 gets that 25 milligram dosage. But now 11 pounds gets it, and it's going to be that dosage all the way to 17 pounds. So here is, this is 12, so 15, 16, 17. It's going to be pretty close to the 18 line there, and then we're going to draw the line between. And so that means every weight in between 17 all the way to through 11 pounds will get that amount. And then at 75, I've got a solid circle on 17, because a 17-pound child will get the 75 milligram dosage all the way to 22. So this value is 21. 22 is going to be about right here. It's going to be an open circle again, and the line drawn to it. And then at 22 pounds, you get the 100 milligram dosage. So it's going to be a solid circle all the way to 27 pounds, which will end up being right here. And then we go ahead and draw the line between. So that's a step function. It's a type of piecewise function where the domains change depending on where you're at on the graph. So those are the types of problems that you're going to see on tonight's homework. Good luck.